Okay, hello everyone. I want to talk about velocity that is constant in each segment, or for each interval we will see constant velocity. However, when we look at different segments, we can see that the velocity can be varied. For instance, if you will look at this graph of v of t, when we're going to look at the first segment from 0 to 5 seconds, we see constant velocity of 2 meters per second. However, the second segment, or the second interval of time between 5 and 15 seconds, we can see that we have different constant velocity, which is 4 meters per second. Okay. Now, what also we know that when time is 0 seconds, the initial position is 0 meters. Okay, let's look at the questions. Part 1, find x of t for each segment. Now, of course, we're going to use this formula of linear function of x of t. Let's look at the first segment between 0 and 5 seconds. We know that when time is equal to 0 seconds, initial position is 0 meters. And of course, for this first segment, the the constant is, the velocity is constant of 2 meters per second. Okay, let's substitute all those parameters with those values. And we can see that when time is 0 seconds, the initial position is 0 meters, and we have also constant velocity of 2 meters per second for the first segment or interval of time. Now let's go to the second segment or second interval of time between 5 and 15 seconds. We need to understand that this function of x of t, even though we see that when time equals 5 seconds, the function of x of t will be continuous. Okay, we won't see jumps because I cannot see myself at the time of 5 seconds, let's say, if it is axis of t and this is axis of x. Okay, now let's assume that I have something like this. When the time equals 5 seconds, I have the same position, okay, for the first segment and the second segment, because if I will get something like this is not true, because at the same time of 5 seconds, I cannot see myself at the same at two different positions. Okay, I always have the same position, and the function is continuous. It is very important. Now, also, I need to understand that the final position of the first segment when t equals 5 seconds, it is also the initial position of the second segment. Okay, which means that I'm going to use this function of x of t to find the initial position for the second segment when we're going to substitute the t of 5 seconds in this function, so we can find the initial position for second segment, which equals to 2 times 5 equals 10 meters. Now we can find the second function of x of t for the second segment. At time of 5 seconds, okay, the initial position is 10 meters, and we also know from the graph that velocity is constant, equals to 4 meters per second. Okay, also you can write down the x of t in this method. This function lives in this segment, and this function lives or exists only in this segment or interval of time. I mean, this function is only lives here, okay, and this function only exists here. Now let's try to draw the function of x of t. Okay. Also, I want to find what is the final position when t equals 15 seconds. Of course, we're going to use this formula. Okay, we're going to substitute t that equals 50 seconds here, and we get that the final position of this object is 50 meters. Okay, so let's try to draw this graph of x of t. We know that initial position when time equals t 0 seconds is 0 meters. We also calculated that when t equals 5 seconds, that the position is 10 meters. Okay, and we also calculated a few seconds ago that when time equals 15 seconds, the position is 50 meters. Okay, and this is how we, of course, if you notice that the slope is actually velocity, the slope would be 10 meters per second for first segment, and the slope, or actually it is velocity equals 4 meters per second for second segment or second interval of time. Okay, now the third part, we need to calculate average velocity. Now the formula for average velocity is equals delta x divided by delta t. Now I'm gonna use two methods to calculate this average velocity. The first method is when we're gonna use function of x of t. We know that initial time is 2 seconds, which belongs to first segment, and t final equals 10 seconds, which is it belongs to second segment. Okay, because we know that initial time 2 seconds and it belongs to first segment, that we're going to use function of x of first segment, okay, which was 2 times t. We're going to substitute t with 2 seconds. 2 times 2 is 4 meters, which means that initial initial position when initial time is 2 seconds is 4 meters. Now, if we want to calculate the final position, we're going to use the second segment, which was equal to 10 plus 4 t minus 5. And we're going to substitute t, this t, with 10 seconds. And finally, we get that final position is 30 meters. And finally, we can calculate average velocity. Okay, we know that final position is 30, initial position is 4, 30 minus 4 equals 26, t final minus t initial is 8, 26 divided by 8 will give us the value of 3.25 meters per second. This is the average velocity between 10 and 2, between 2 and 10 seconds. Okay, now second method, we're going to use the area under graph of v of t. Okay, I hope you know this, that the area under v of t, okay, it's actually displacement, okay, delta x. Now, if we want to calculate displacement between initial time of 2 seconds and 10 seconds, we need to calculate two areas, 1 and 2. Okay, now it is very simple. The first area is base times height. Okay, base equals 5 minus 2. This is the base, as you can see here. Okay, 5 minus 2, it is actually 3, times 2 will give us 6. Plus the second area is this one. Base is 10 minus 5 will give us 5, and the height is 4. 4 times 5 will give us 20 meters. And finally, The delta x is given by 26 meters. Now we can calculate the average velocity, which also, again, it is delta x divided by delta t equals to 26 divided by a. And finally, we get this value for average velocity, which equals the same value as when we used first method, the same value. You can choose which way you want to use to calculate it. Okay, both are okay. Sometimes we can ask, okay, you found the average velocity, please show how this average velocity could look like in function of x of t, I mean graph of x of t, and also in graph of v of t. Okay, now what you have to do is just you need two coordinates, initial and final. In our case, when initial times equals to 2, the initial position was 4. When final time was 10 seconds, final position was 30 meters. And what you have to do, just draw a straight line between those two coordinates. And this slope, okay, actually is average velocity. Now, how we can draw average velocity when we're gonna use function of v of t, okay, initial time of 2, final time of t, and we found that average velocity, the value of average velocity is 3.5 meters per second, and if you will calculate all this area between 2 and 10 seconds when height equals to average velocity, which means all this area, it will give us the delta x. Let's try to prove it, okay? That delta x equals to base is 10 minus 2, which is 8, times the height, okay, 3.5, or we can also say that it equals to 7 divided by 2. 4 times 7 equals 28 meters, okay? Let's check. Did I make mistakes somehow? Just a second, please. Okay, from 2 to 5, 3 times 2 is 6. Okay, 5 times 4, 20, 26. And what was the mistake? 3.5. 2.5. Oh, I'm sorry. I see my mistake. This is actually 3.25. Okay. And when we take and substitute 8 times 3.25, then we get the same result for displacement, 26 meters, as we calculated in the second method and also calculated in first method here, 26. Okay, sorry for the miscalculation here, but that's it. I'm gonna see you in the next videos. Thank you.